Okay, so in class we did an activity, and what we discovered was something called the central limit theorem for proportions. So what the central limit theorem for proportions says is that for sample proportions to be approximately normal, we require that n times p is greater than or equal to 10, and n 1 minus p is greater than or equal to 10 also. So if this is true, then the sampling distribution of the sample proportion is this. So p hat is distributed normal. This is the mean, and this is the standard deviation. Okay. So basically, what this is basically saying is that if I get a lot of proportions and I were to graph them, they will look normal, okay? And the mean here is going to be p. Now, what I require is that these things are greater than or equal to 10. So my sample has to be really, really large. Here, n is what we call the sample size. And p is just the proportion or the probability, what we believe. Usually this would say what we believe proportion is. Okay, so this is what we believe from the very beginning. Okay, all right, so I'll give you an example of when we use this and how problems will be worded. So here's my example. So Shaquille O'Neal has a lifetime free throw percentage rate of 52.7%. Suppose that his free throw attempts are independent from one another. So can the central limit theorem for proportions, which is what we just talked about, can this be used when he shoots 40 free throws? What about with 15 free throws? Okay, so this is basically saying, is 40 free throws large enough for me to say that his percentage, percentage rate or the amount of free throws that he shoots is going to be somewhat normal? Okay, so one thing to really know is that these are the things that we need to be testing. So when n is equal to 40, let's see, can we really do this? Okay, so n equals 40, do we know what p is? Do we know what we believe Shaquille O'Neal's percentage is? Yes, so that was given to us. That's going to be 0.527, okay? All right, so can I use the central limit theorem for proportions for this? So what I require, I need to make sure that np is greater than or equal to 10, and also n 1 minus p is greater than or equal to 10. That's what I require. And here is 40. Multiply this by 0.527, okay? So when I use my calculator, I'm gonna put 40 times 0.527, and what I'm gonna get is 21.08, and you can see that this is actually greater than 10. Okay, now we also have to check this one. We have to make sure that this is also true for this one. So I'm going to have 40 times 1 minus 0.527. Is this greater than or equal to 10? Okay, so I'm going to take 40. I'm going to multiply it by 1 minus 0.527. And what I'm going to get is going to be 18.92. And you can see that this is greater than or equal to 10. Okay. So can we use it with when n equals 40? The answer is yes, we can use it. Okay, now can we use it when n equals 15? Or is that too small? Okay, so p hasn't changed, it's still 0.527. Okay, so we're gonna have 15 times 0.527. Let's see what that equals to. So 15 times 0.527, and what we get is 7.9, and you can see that this is not greater than 10, so we can stop there. We can say that no, we cannot do it for n equals 15. You don't need to even check the other one because this one already failed. Okay, so now that we have that, let's do part B. So what we want to figure out is we want to write the sampling distribution when Shaq shoots 40 free throws. So we already know what the sampling distribution looks like. Okay, the sampling distribution is just the thing that we just had up here. This is what I'm looking for. Okay, so we already saw that with 40 free throws we are able to do it. Okay, so we're gonna write p hat is normally distributed with a mean of p and a standard error of p1 minus p over n. Okay, now all I gotta do is just plug everything in. So p hat is normal. P is just 0.527. And then square root of 0.527, 1 minus 0.527 divided by n. So in this case, it's going to be 40. Okay, so let's see what we get. So normal, the mean is still the same. And now we can just put that into our calculator. So we're going to put square root of 0.527, 1 minus 0.527 divided by 40. Okay, and my answer is going to be 0.079 because I wanted to round it to 3 decimal places. Okay, all right, so now this is just the only thing that I'm looking for. Okay, because now I know what the mean is, and I also know what the standard error is. Okay, all right, so now that I have that, okay, let's do part C. So part C is saying, what is the probability that he makes more than 50% of his free throws? Okay, so now what we're going to do, we're going to be using the thing that we found in part B. So what is the probability? So we're going to draw this normal curve because I know that this is normally distributed. The mean in this case is going to be 0.527 because that's what we just figured out. And we want to find the probability that he makes more than 50% of them. So 50% is just 0.5. So this is going to be right below it. So this is 0.5. And we want to know what this area is. Oops, sorry, that's wrong. We want to know not this area. We want to know the other area. We want to know more than 50%. Okay, so all of this. So what is this probability? Okay, so now what we're going to get, okay, we're going to have normal CDF, because this is still the same thing that we're doing. So normal CDF. My lower bound is going to be 0.5. My upper bound is not going to be all the way to positive infinity, so it's going to be 1 million or a really, really large number. My mean is just equal to 0.527, and my standard sigma, or standard deviation, standard error, is going to be 0.079. Okay, so notice that this problem is very similar to the normal problem. It's just that you have an extra step, and in an exam, what I'm going to do is I'm going to make you guys write this so that you guys can already have the mean and the standard deviation or standard error already there, and all you got to just do is just plug it into the normal CDF. Okay, so now let me put it in the calculator. So we're going to have seconds, VARS, going to go down to normal CDF. My lower bound is going to be 0.5. My upper bound is going to be a really, really large number. My mean is going to be 0.527. And my sigma, 0.079. Okay? So this is what I'm going to get. If you guys hear a noise, it's because there's a dog here. Okay, so I'm going to press enter, and I'm going to get 0.6, oops, what happened to it? 0.6334. 0.634. Okay. All right, so this is the probability. So the probability that he makes more than 50% of his free throws from that 40 that he just threw is going to be about 63%. Okay. All right. So now part D is saying, what is the probability that he makes less than 40% of his free throws? Okay. So less than 40%. So we're still using the same distribution. This is going to be 0.527. Less than 40%, that's just going to be 0.4. It's going to be down here. And so given that he already has a percentage rate of 0.527, what is the chances that out of the 40 free throws that he shoots, he will score less than 40% of them? Okay, so we're going to still use normal CDF. My lower bound in this case is now going to be negative infinity, because that's where it's going to start. It's going to go all the way to 0.4. Mean is going to be 0.527, and my standard error is going to be 0.079. Okay, so now let's put that into our calculator. So I'm going to have second VARS, normal CDF, a really, really low number. Then my upper bound is going to be 0.4. Then everything is the same. Okay, so what I get is 0.054. Okay, that's what my answer is. So the probability that he makes less than 40% of his free throws from the 40 that he shot is about 5%. So not very likely. Okay. So so this is how I would set up a couple problems that deal with the central limit theorem. I will probably ask you from the very beginning, can the central limit theorem for proportions be used, so that you know that I'm talking about this thing. Then I will ask you for the sampling distribution, and basically what I'm saying is like just want the mean and the standard deviation. I'll probably even just give you fill in the blank so you can just fill it out, and then just give you some general problems using normal CDF. Okay, that's it.